In this video, we learned how to do a linear model of some real data. These numbers you see here corresponds to the population of Nigeria from years 2010 to 2019. What do we want to do? What we want here is to get a line, a linear model that approaches the data so we can do some prediction for the future. So what we want basically is a formula of the type f of t equals a plus bt, where t is the time, so we can see what the population, or we can guess what the population of Nigeria will be in year 2020. To do that, what we need to do is guess somehow a line that comes close to the data and then substitute t equals to 220 to get the population in 2020. But how do we get that line? A line has two parameters, b, which is the slope, and a, which is the y-intercept. We have to get these parameters from the data. We could use all the data from 2010 to 2019, but it's much smarter if instead of that, what you do, you use to construct your line, you use the data from 2010 to, sorry, this is coming a little bit messy, let me erase it. So instead of that, to build the line, you use the data from 2010 to 2018. And check in 2019 whether your line is actually good, in the sense of the function you get in 2019 is close to your real data. If the function is good, then you can use it to predict. If not, you will have to do a new line. So how do we do this line? What we need is the slope of the line, first of all, because it's easier than the intercept. So b is how much the line grows, the speed of growth of the line. So there are many ways to do it. For example, we could take from b the population in 2011 minus the population in 2010. That will be the slope. Really speaking, the slope b is equals to the population in 2011 minus the population in 2010 divided by 2011 minus 2010, but the denominator is 1, so our slope becomes the difference. So that gives us a way to compute the slope. You take the population in 1 year and subtract from it the population in the previous year. But the question is, so why taking 2010 and 2011? Why not we take 2011 and 2012? And so on. Well, the best way then it can be, for example, if we take the slope b between 2010 and 2011, then between 2011 and 2012, and all the way up to 2017 and 2018. Remember, 2019 we are not using. We are going to use it to check and do the average of those slopes. That way, we get one slope. I'm going to call it m to differentiate from that b we have used till now. And we have our line, f of t equals a plus m times t. This I'm going to compute I'm going to compute in Excel in the second part of this video. Now, this is a little bit complicated. It turns out to be much simpler. Instead of using t, we use here t minus 2010, the number of years since 2010. Then how do we compute the number a? Well, you look at the value of this function in 2010 will be a plus m. Remember, m we are going to compute it with Excel, but it's a number computed. 2010 minus 2010, which is a. Therefore, we have the function t will be, here is the a, which is the population in 2010. So the function will be population in 2010 plus our average slope times t minus 2010. And that's what we're going to do with Excel. After finding this formula, we'll put f of 2019 to see whether our approximation is good or not. And assuming it's good, we'll put f of 2020 to predict what the value of the population in Nigeria will be in 2020. So let's go over to Excel. With the population of Nigeria. Before anything else, let's make a graph to see if this really looks like a line. This graph, actually this Excel is all done in a Mac, but you have similar thing in Windows. So you go to the first year here and highlight all the years, go to Insert, and this chart, which is a scatter plot, we choose the first one. Here is your scatter plot, and it looks pretty much like a straight line. So let's try to construct our line from what we have explained in the text before. For that, we have the slope to take the slope first between consecutive years. So we put here, this is equal to this number minus this number, and that gives the slope between 2010 and 2011. We put it all the way up to here, and we get all the slopes. And we're going to take now our slope, B or M, the slope is going to be we put here equals to the average of the slopes we just computed. That's the average of the slopes. That's it. So our function, our line, is going to be equals to this number plus the slope average, which is this. Sorry, let's forget this thing for the time being. Let me write in the formula. So here we are going to have our approximation formula, f of t. And what do we do for that? So we put for every year, we equals to this number plus the slope times and the year we have here minus 2000. Okay, one has to be slightly careful because right now, if we pull this rectangle, try to this cell all the way down, something is going to go wrong. We have to fix the population. This parameter is fixed. So here we press F4, and F4 fixes that all the time. And this parameter, which is the average of the slopes, have to be fixed. So we press F4. And what it says, this formula, is simply that fixed population of 2010 plus fixed average of slopes times the time minus 2010. Now we can extend it all the way to 2019. There it goes. What is our error? What is the error done in 2019? Okay, that will be equals to the actual population minus the predicted population by our model. That's the error. Okay, comes sort of okay. Let's see in relative terms what is the error. Error divided by the population in 2019. That will be equals to this number divided by population in 2019. It's very small. It's 0.2%. So our model is good. So let's try to extend our model to 2020. There it goes. The population of Nigeria in 2020 will be 205,217,626.